大家好，今天跟大家一起来看一下老师课上讲的内容。然后因为这节课很长，有2个半小时，所以我在这边只会挑一些重点出来，然后结合老师课上讲的内容，分享一些我个人的理解或者一些大家可能需要去注意的东西以及一些老师可能课上没有提到的东西然后大家有时间呢，一定还是要去看原片老师上课讲得非常好，然后这门课它也是由专业的摄影团队拍摄的，非常好的还原了哈佛的课堂然后在开始之前呢，我想先给大家介绍一本书，就是这本的 C Programming Language， 它是由 Knigan 跟 Ritchie 这2位 C 语言的发明者、C 语言之父写的一本介绍 C 语言的书。虽然它是1988年出版的第2版，跟现代 C 语言可能有一点点的出入，但它仍然是一本非常好的入门 C 语言的书。我以前学 C 语言的时候用的也是这本书，它写的是相当的原汁原味、简洁干练，没有废话可以用短小精悍来形容。它是一本薄薄的小册子，然后大家去看的话也花不了很长的时间然后网上也有很多 PDF 的版本，大家可以去找来看。如果说入门 C 语言推荐一本书的话，我只会推荐这一本然后接下去我会从这个地方开始给大家放。
So let's start to apply some terminology to these tokens first. So what we're about to see, what we're about to write, henceforth, we're going to start calling source code. Code that you, the human programmer, write is just henceforth called source code. Doesn't matter if it's Scratch, doesn't matter if it's C, doesn't matter if it's Python before long. Source code is the general term for really what you and I as human programmers will ultimately write. Of course, computers don't understand source code, it turns out. Computers don't understand Scratch and puzzle pieces per se, or C code like we're about to see. They only understand this, which we called what last week? Yeah, so this is binary, zeros and ones, but really it's just information represented in binary. And in fact, the technical term now for patterns of zeros and ones that a computer not only understands how to interpret as letters or numbers or colors or images or more, but knows how to execute as well, henceforth is going to be called machine code, to contrast it with source code. So whereas you and I, the humans, write source code, it's the computer that ultimately only understands machine code. And even though we won't get into the details of exactly what pattern of symbols means what, you'll see that in this kind of pattern of zeros and ones, there's going to be numbers, there's going to be letters, but there's also going to be instructions, because indeed computers are really good at doing things, addition, subtraction, moving things in and out of memory. And suffice it to say that the Macs, the PCs, the other computers of the world have just decided as a society what certain patterns of zeros and ones mean when it comes to operations as well. So not just data, but instructions. But those patterns are not something we're going to focus on in a class like this. We're going to focus on the higher level software side of things, simply assuming that we need to somehow output machine code. So it turns out then that this problem we have to solve, getting from source code to machine code, actually fits into the same paradigm as last time. But the input in this case is going to be source code on the one hand, like that's what you and I ideally will write so that we don't have to write zeros and ones, but we need to somehow output machine code because that's what your Macs, PCs, phones are actually going to understand. Well, it turns out there's special programs in life whose purpose is to do exactly this conversion, convert the source code you and I write to the machine code that our phones and computers understand. And that type of program is going to be called a compiler. So indeed today, we'll introduce you to another piece of software, and these come in many forms. We'll use a popular one here that allows you to convert source code in C to machine code in zeros and ones. Now, you
好，这里老师讲了一件什么事情呢？就是说我们的源代码其实是面向我们人的，我们人写的，我们人读的。然后机器呢，它其实只认识机器码，它不认识我们的源代码。我们需要一个东西把源代码可以转化成机器码，这样机器才能运行我们的程序那这个东西它就叫做编译器编译器现在在大家脑子里有一个概念就可以了，你现在可以简单的认为它就是把源代码转化成机器码的一个东西然后因为我们的源代码是面向我们人的所以我们有几个原则要遵循一个是它的正确性首先我们要保证我们源代码是正确的，这样我们的机器才能正确的运行我们的程序 当然正确性是最基本的，除了正确性以外呢，我们要有良好的代码上的设计，这里的设计可能就包含了一些代码逻辑的复用抽象等等这些东西然后大家现在对这些东西可能概念不是很多，然后我觉得大家可以先从模仿开始。代码这个东西也是有大家自己的审美，然后大家从刚开始学习编程的时候，可能就是要有这样的意识去培养自己的代码方面的审美，然后这个东西就跟我们可能不懂得穿搭的人去学一些穿搭博主他的穿搭一样，然后后面才形成自己的风格。代码这个东西一开始大家什么都不懂的时候也可以从模仿开始，从模仿老师课上讲的代码开始，写的代码开始跟着一起敲，然后后面可能可以去 GitHub 上面找一些优秀的项目，看一下一些大神他们是怎么写代码的，然后学习他们写代码的思路这样一步一步培养好自己的一个写代码的一个设计思路比如说我觉得就有一个简单的原则大家可以开始遵循，就是比如说有2段重复的代码大家就可以开始考虑说能不能把它减少成一段代码从这样简单的思维去开始实践然后最后一个 style 这里讲的更多的可能是代码规范、代码风格这个东西因为大家上这节课的话可以先遵循跟着老师的代码一起，然后遵循老师写代码的风格然后这个东西如果大家以后当程序员，然后进入到公司去工作有一个团队在团队内部可能有自己的代码规范，或者是公司有自己的代码规范风格大家一个团队里面只要保持同一种代码风格跟规范就可以了。然后现在也有很多辅助的工具可以去帮我们检测这些代码风格我觉得这个地方大家就没有必要特别的纠结我以前认识有些人他可能会特别纠结是2格缩进还是4格缩进现在我觉得就是没有特别的必要，因为一个团队里面你进入到不同的团队，每个团队可能已经养成了不同的风格，然后只要一个团队里面大家可以遵循一种风格去开发就可以了好，然后后面 VS Code 的这部分我之前已经出过一期视频讲这部分了，然后大家如果还没看过的话可以回去看一下，我这边就不放了。然后下一部分我会放一下这个 Hello World 就是我们写 C 的第一个程序。一般来说我们学习一门新的语言都会从一个简单的 Hello World 的程序开始，就是用这门程序的语言用这门语言去在屏幕上输出一行叫做Hello World 这行话开始去接触它的语法，然后我们这门课也不例外。从这里开始大家可以打开 Discord， 然后跟着老师大家一起敲代码。
My first file? Well, perhaps the easiest way is this. Literally run the command code, and then the name of the file you want to create. Notice that I deliberately end the file with .c in lowercase. Notice that I've deliberately lowercase the whole file name, and these are just conventions. You could use a capital H, you kind of could use a capital C, but just don't do that. Follow best practices so that it's consistent with what most everyone else would do. When I hit enter, I just get an empty tab, just like the screenshot a moment ago. And it's in this tab where I can now write my very first program in C. Unfortunately, it's not quite as user-friendly as Scratch, where you drag and drop a couple of puzzle pieces and boom, it's done. So I'm going to do this from memory, but this too will become familiar to you over time. I'm going to include something called standardIO.h. I'm going to type int main void in parentheses. On a new line, I'm going to insert some curly braces, as we'll call them, and then I'm going to type printf, and then some parentheses, and then in quotes, hello, comma, world, then a backslash, then a lowercase n, then a close quote, and then a semicolon at the very end of the line. So all I've done is recreate, just from memory, that very first program. In a little bit, we'll make clear what most of this does, but for now, let's just actually run this thing. And just like I clicked the green flag last week for the first time, let's actually compile and run this program. If it were your Mac or PC and Google or Microsoft or someone else had made the software, at this point in the story, we'd be double-clicking an icon. But we can't do that yet. This is still source code, so I'm gonna click back down in my terminal window. Notice I have a second $sign below the first, which just means it's ready for a second command. And now the command via which to make this an actual program, to compile it from source code to machine code, is going to be quite simply make, and then the name of the program I want to make. Slight subtlety, I'm omitting deliberately .c, because the program I want to make, I just want to call hello. So don't write make hello.c, just write make hello. And this program make is essentially our compiler. Technically speaking, it's a program that automates the compilation of my program for me, but it is going to see that I've typed the word hello. It's going to automatically look now for a file on the hard drive called hello.c and convert it from source code in C to machine code in zeros and ones. So if I didn't make any typos, enter. Nothing seems to happen, and that's a good thing. Almost always, if nothing gets outputted on the screen, like you did good, like you didn't make any mistakes, you didn't get yelled at, there's no error messages. So this is actually a good thing. How do I now run this program? Well, notice I've got a third $sign, which just means I'm ready for a third command. And now I'm gonna go ahead and run ./hello. And this is admittedly a little weird that you have to do ./, but for now, just take on faith that this is how you run a program called hello in your current folder, in your current directory in this cloud-based environment. All right, crossing my fingers again, hitting enter, and voila, my very first program in C, hello world. And now, let me go ahead and reveal the file explorer that I proposed exist earlier. I'm just gonna use the keyboard shortcut to reveal that. And generally I keep it closed because I don't really need to know constantly what files are in my account. But you'll see now in the file explorer, similar in spirit to a Mac or PC, but graphically a little different. Here's my file, hello.c. It's highlighted because I have that tab open, but now there's a second file here called just hello. That's the name of my program. So if you were on a Mac or PC, you would ideally double click that thing. You can't do that in a command line environment. You have to run it down here, but that's all we've done. We've created a file called hello.c, and then my compiler made the program from that. Well, it looks a little something like this. If I take away all of the colors, and then just for discussion's sake, let me go ahead and color it a little more like Scratch. Recall that our very first Scratch program that just said hello world on the screen had a when green flag clicked icon, puzzle piece, roughly an orange, and then a purple say block beneath it. So whereas this is the C version, if we rewind to last week, this was the same program in Scratch. But what's happening now is exactly the same. So if you think back to last week and you've got some function, like the say function, in purple, that might take one or more arguments, like inputs that influences what it says on the screen. And then functions, recall, can sometimes have side effects, right? Like the speech bubble appears on the screen. So last week, when we used the say block and we passed in an argument of hello world at left, we got this visual side effect on the screen that says now, hello world in the speech bubble. And that's exactly what just happened in VS Code, but much, much more textually. And let's look a little closer now at the code itself. Let me wave my hand at the equivalent of the when green flag clicked part of my code, and let's focus only on the say block in Scratch and the corresponding function in C. So if I step through this and I wanted to convert what we did last week with the say block to C, I would first use the print function. Although that's actually a bit of a white lie, it's actually the printf function. Printf means formatted, and it's just a function that allows you to format text on the screen. There is no say function in C. There's a printf function. What MIT did down the road years ago was they took what existed historically as printf and they simplified it for a broader audience by just calling it essentially say instead. But notice that now, if I want to convert the Scratch code at left to C code at right, it's sort of the same shape. So MIT deliberately used this white oval, if only because it kind of conjures this idea of having parentheses too. So on the right, if I want to pass an argument or an input to the printf function, I use an open parenthesis and a close parenthesis. In those parentheses, I then type whatever it is I want to print on the screen, in this case, hello, world. But notice I've deliberately left some room because you need some extra keystrokes in the world of C. anytime you type out some text, otherwise known as a string of text, to use computer science jargon, you need to quote it, in this case with double quotes. Double quote at the left, double quote at the right. And notice too, I'm going to include some slightly cryptic symbol here too, \n, which I also typed and said verbally earlier. And then one last nuisance at the end of this, which is a semicolon. So suffice it to say, this is why we start with Scratch. This, drag and drop, you're good to go. In a language like C, printf, parenthesis, double quotes, the text you want, \n, semicolon at the end. There's just so much syntactic overhead. But at the end of the day, it's just a function. And you'll get used to these sort of nuisances like the parentheses, the quotes, the semicolon, and the like. But things can very easily go wrong, and it's very easy to make mistakes even with lines of code like this. So let me do this. Let me go back to VS Code where I have the exact same code. Notice that on line 5 is exactly that line of code. So this is the equivalent of the say block. And let's consider what mistakes I may make early on, or even now, 20 years later after learning this, that are quite common in general. Suppose I forget the semicolon there. So easy to do, you will do this eventually. Let's see what happens now when I go back to my terminal window and try to compile my code again. Just to keep things tidy, I'm gonna clear my screen, but that's just for lecture's sake so that we can focus only on the most recent command. But I'm gonna go ahead now and rerun make hello. This will ensure that my program is recompiled. And this is a manual process. I changed my code. The zeros and ones on the hard drive have not changed. I need to recompile it to output the latest machine code. So here we go. I'm going to hit enter, crossing my fingers as before. But again, I removed the semicolon by accident. Oh my God, there's like more lines of errors now than there are of actual code. And this too takes some getting used to. The programs we're using were not necessarily written with the least comfortable audience in mind, but really professional programmers back in the day. But through practice and through experience and through mistakes, you'll start to notice patterns here too. So here's what I typed, make hello after the $ prompt. Now I get yelled at with as follows, hello.c:5:29. Well, what's that referring to? I've screwed up somewhere on line 5 on the 29th character on that line. Generally, the specific character is not that useful unless you actually want to count it out, but line 5 is a good clue. Why? It means I screwed up somewhere on line 5 here. All right, well, what is the error? Expected a semicolon after expression. And this error is actually pretty obvious now that I see it and I realize, oh, wait a minute. All right, here's my line of code. Here in sort of ASCII art, so to speak, textual, text representing graphics, it wants me to put in green here this semicolon at the end of that line. One error generated, built in, so some esoteric stuff there, but my program did not compile. When you see an error like this, it means it did not work. So what's the fix? Well, obviously, the fix is to go back up here, put the semicolon there, and now if I recompile my code with make hello, I won't clear my screen just yet, just to show you the difference. Now, it just worked. So we're back in business as before. All right, let me pause here though and ask if there's any questions about what I just did. These error messages will become frequent initially. Yeah. Aesthetically, suppose that I omit whatever this sequence of symbols is, \n, since I'm not really sure at first glance why that's even there. Does anyone want to conjecture, especially if you've never programmed before, what might happen now if I recompile and rerun this version of the program? I left the semicolon, but I took away the \n. Any instincts? All right, well, yeah. It will. The next $sign will appear right after my hello world, but what makes you think that? Exactly. \n is actually a special sequence of symbols that creates a new line. And so, to your point, if I recompile this program, make hello, enter, no syntax error, so it did compile this time. So you don't need the \n, you do need the semicolon. But if you don't have the \n, watch what happens when I do /hello this time. Now, indeed, I see hello, comma, world, and then a weird $sign. And this is still a prompt. I can still type commands at it like clear, and everything gets cleaned up, but it just looks kind of stupid. If I run it again here with /hello, you know, it's just not very user-friendly. It is convention that when you're done running your program, you should ideally clean things up, move the cursor to the next line for the user. And so the \n is simply the special symbol, otherwise known as an escape sequence, that C knows means move the cursor to the next line. In other languages, Python among them uses the same symbology as well. Now, if I go back to the code here, and for instance, I try to do this differently, like suppose I don't put the \n, I just hit enter, like a normal person would in Google Docs or Microsoft Word. Let me go ahead and try compiling this program. And this you would hope would work, right? You would hope this would print out hello world and then a blank line because I moved the cursor to the next line. But no, if I run make hello now and try to compile that, C does not like this. Now I get a different error, still on line 5, this time starting at character 12. Error missing terminating double quote character, and then some other esoteric stuff. And then this does not sound good. Fatal error this time. Too many errors omitted, stopping now. So I really screwed up here. So why can't I do this? Just because, like the humans who designed C decided that if you have a string of text, it must stay on the same line. It can get really long. It can soft wrap. That is without you hitting enter, but you can't hit enter.
好，这里老师基本上介绍了我们这个 Hello World 第一个程序，最基础的语法，然后我这里有一些东西想给大家说一下。首先呢，是我上次介绍 VS Code 的跟终端的时候，忘记说的一个事情，就是我们在终端里面，用 code 这个命令，然后跟上一个文件夹的路径，或者是文件的路径，是可以直接在 VS Code 里面打开这个文件。比如说我这下面有个 debug 的目录，然后我直接 code debug 的话，它是可以直接打开这个 debug 这个文件夹。然后比如说我现在打开 hello.c 这个文件，我是可以直接打开它。然后我这边有一个跟老师这边一样的 Hello World 的文件，然后我们跟老师一样尝试在这里做一下编译。这时候你们会发现，这里我输出了一行命令，在本地编译的时候，它会输出一行命令。这个是什么意思呢？因为 make hello 这个命令 make 这个命令，它实际是执行了，它有一个默认的行为，就是它实际执行的命令是这一条。那这一条命令是什么意思呢？它是 CC 是 C 编译器的意思，而在 Mac 下面默认的 C 编译器是 CLang， 然后在有的系统下面可能是 GCC， 然后大家现在只需要知道 CLang 跟 GCC 都是 C 的编译器就可以了，不需要就特别知道这两个有什么区别，或者它具体做了什么。然后这一行命令的意思就是说C 编译器然后把 hello.c 这个 C 的原文件-O 呢是 output 这个意思，相当于做了一个编译，然后输出 hello， 输出成 hello 这个可执行文件，然后经过这么一编译呢，我们这里就有一个 hello 的可执行文件，可以发现它的颜色跟文件夹跟文件的不一样，它是一个可执行文件。然后我们执行一下就会发现，屏幕上输出了 Hello World。然后这个文件基本的语法，老师已经讲的比较清楚了。然后老师用了跟 Scratch 来对比的一种方式，我觉得非常好。我前几天还刷到一个视频，说现在青少年学那 Scratch 没什么用，到了学真正的编程语言还需要再学一次。当然听完这节课我不这么认为如果就是你可以把 Scratch 然后跟我们真正的编程语言去做一个类比的话，相信 Scratch 对你也是有帮助的。然后这边呢稍微重复一下，这个 int main 它是一个 C 语言程序入口的意思，这个就是规定了我们 C 语言的程序必须有这么一个入口，让程序知道从哪里开始运行。然后 printf 呢，它是一个用来输出到屏幕的一个参数。然后函数呢，它就是传入一个参数，然后有一个对应的输出。可以回想一下我们之前讲 Scratch 的时候，然后这一个用双引号括起来的，它是一个字符串， 然后这整个字符串就是这个 printf 的参数。我们去调用一个函数的时候是用两个括号括起来，然后在里面传它的参数。然后这个仿斜杠 n 呢，它是一个换行符的意思。然后这里接下去老师会讲这个头文件的作用，这一行的作用。